I actually had a very interesting lead into today. Is anybody here a fan of Thai iced tea? Yeah? Have you ever seen Thai iced tea where they don't give it to you in a single glass? If you go to Tin Drum at Atlantic Station, they actually have the tea where you serve yourself with Thai iced tea. So I enjoyed maybe a little too much of that before I got here today. Now I'm all wired up because I never get that much, but I recommend that. So today I'm hoping we can have some fun with this today. There is some audience participation at a few points in time, and I want to walk you through a couple of different themes, some of what's happening in the big data and analytics space, a little bit about some of the cultural and political aspects that organizations are struggling with, and then some thoughts around operationalizing it at the end, and how do you take a lot of the insights people have managed to get and then do something with them, which is the challenge in a lot of the big companies we work with. So one of the first things I'll just point out is that I see a huge parallel between the internet and big data, in the sense that there was a huge internet bubble back in 99 or 2000, and a lot of money was lost, a lot of companies went under, but if you go back and look at the wild hype of 1999-2000, I believe you'll find that we've easily overshot even those wild claims today, both on our personal life impacts and business impacts. So the key is that the bubble of the internet had nothing to do with the internet not being real and not being more than everything people talked about. It was about people thinking it'd be a little too fast, cheap, and easy to actually get there. And that, I believe, is exactly the kind of place we are with big data today. It's very real. In 5 or 10 years, I think we're going to surpass all the hype of today. But the problem is today, there's too many people thinking that it's just fast, cheap, and easy. So I think my blog a few months ago was around the idea that just as any company with an I or E in its name in 99 would have been funded with a lot of money, free-flowing, I think today, if I went out and got some venture capitalists and with a straight face said, I need $5 million for my cloud-based, in-memory, machine learning, big data, analytics as a service company, okay? See, if I cannot smile when I say that, I think that's $5 million right there. So it'll be good to get through this hype period. We are going to see a little bit of carnage out there. There's way too many companies competing in the exact same space in some of the startup place, but 5 or 10 years, it's going to be worth it. So don't give in to the despair around the hype bubble popping a little bit. It's a necessary step. And one of the very interesting things to me is that it's not even clear what industry some companies are in anymore. And this is a big struggle we see a lot of the large organizations having. So, for example, if we had surveyed the group, what does Nike do? Everybody would probably have said something along the lines of sportswear, clothing, etc. And that's not an incorrect statement. But one of their most popular products today is this little thing called a fuel band. How many people have a fitness band of some kind on today? About a third. I have one right here. It's actually a Fitbit. And it's interesting because this has nothing to do with clothing or sportswear. In fact, when you think about it, it's got sensors, transmitters, chips. This is a high-tech electronics device. And as of today, Nike's manufacturing these, although they're considering getting out of the actual manufacture of it. So Nike's suddenly in the high-tech electronics industry. But you download one of these things, and the first thing you have to do is go get your software. Right? You got to get the software to connect to the device. So suddenly Nike's developing consumer software. And then that software downloads the data from your device, which where does that go? Well, they don't just store it on your phone or your computer. It actually is going to a cloud somewhere. Now Nike's managing data centers on behalf of millions of consumers. And the purpose of all of that is to get the analytics on your sleep and your activity patterns. So it really comes all down to the analytics. Nike's now analytics as a service. So think about the skills it took for Nike to become a world-class clothing company. You needed people who understood the fashion trends, what color is going to be hot, should we cut the collar this way or that way. You had people who had to know the material science, what shoe cushioning will be an upgrade and better for running and so forth. Those skills have nothing to do with what it takes to succeed with a product like this. So that's a huge challenge for an organization like Nike. But there's another trend that I think is even bigger that is the most important, which is, this device on my wrist, it's not very attractive, it's not very sporty, it's not very fashionable, it's sort of nerdy, right? And I say this as a nerdy analytics guy, right? Here's the point. It's just a vehicle. No one buys the fuel band or any similar device because it's fashionable or it's sportswear. You buy it for the analytics, that's the end product. And the physical thing that you're actually purchasing you don't care about at all. It's just to get to the analytics. And this is a trend that's not just here. But if you haven't yet picked a car based as much with a primary decision criteria being the analytics you're going to get from that car's engine from all the sensors, you are going to be doing that very, very soon. And some of the electric vehicles or hybrids already have massive amounts of data and electronics in it. You've got farmers, and we're going to talk about this in a little bit, now with their tractors having sensors all throughout. They're making decisions on what tractors to buy based in part on the analytics that that tractor is going to provide. You can get into the smart grid, just what used to be little transistors and other things throughout the grid that were just tactical items that suddenly have data spewing from them that has potential. So it's really challenging a lot of businesses out there to even think about what business are they in and what is it that they actually do and how do they stay relevant and succeed moving forward. So another huge trend is around the monetization of data and analytics. And this is an important trend too because when I first started in my career, and virtually all the analytics today, if you think about it, the analytics are supporting the core business of whatever the company does. So if Coke down the street is going to do a promotion, they're going to do a promotion one way or another. Analytics help make the promotion better. They're going to price their products in the stores one way or another. The analytics help us price it more effectively. They're going to have things delivered through the supply chain. Analytics help that run more smoothly. The point is analytics were always supporting the core business model. We now have companies breaking out of that mold and having the data and analytics be a revenue stream directly. So, the obvious examples are the classic high-tech companies like a Netflix or LinkedIn, where they have products like People You May Know that are completely analytically based. But it's even other organizations finding uses for data that were never intended. So, for example, let's assume you wanted to open a new restaurant site or you wanted to run a billboard. There's a lot of classic methods around site selection, for example, that retailers and banks use and so forth. There's also ways you can price out a billboard. But AT&T knows everywhere I've been based on my phone, and they have to know that to deliver my service. Imagine now, what is it worth if you want to open a restaurant, if AT&T can come to you and say, I can't give you the individual's information, but if you tell me the 3 sites that you think are equivalent based on your classic geodemographic analysis, we can actually tell you exactly what % or how many of our customers drive past that every day. We can tell you if they're driving at 45 miles an hour and they'll go by quickly, or whether they're going to be stuck looking at your restaurant or your billboard for a good 2 minutes at a traffic light or a regular backup. That could really be valuable information to help you pick between sites that otherwise look the same. And in that example, there's data that AT&T had for another purpose that they've repurposed and analyzed and sold, but it has nothing to do with their core business. It's a direct revenue stream. And so these are other things that are popping up all over the place, are people looking for new ways to monetize the data that they already collect in new ways. So one of the things too is that I don't like the term big data so much for 2 reasons. First of all, data isn't something that's very interesting in and of itself, right? Data, a bunch of numbers or a bunch of information stored doesn't do anybody any good unless they're putting it to use for analytics. So I think big data has actually masked really the bigger trend of the rise of analytics. It's forced the issue. It's helped elevate analytics even further. But even at that, I don't like big data because the big component of big data isn't even remotely the bigger challenge, right? Every day in my career, whatever data I was analyzing at the time was a little bit more than we could comfortably handle, maybe a lot more than we could comfortably handle at the time. The size of that has obviously varied over the years, but it's always been a challenge how big data is. The real problem with big data in most cases is the differentness of it. It's that it's fundamentally different in terms of the information it contains. So while sensor data may be mostly structured as it comes out, it's information that we never had before. It's different in structure when you get into things like graph analytics and the relationships between people or things. It's different when you get into text and image analysis. The big challenge is really that different type of information, that different type of structure. The bigness of it's something that we've always dealt with, and that actually is not nearly the challenge to solve as those other pieces. And even at that, what big data, it's really not even about the data, it's about the information. And so there is a huge difference between more data and more information. So I'll give you a real-world example here of the difference. So 10 to 15 years ago, people would have come to our big annual conference, some of our large customers, and proudly discussed how they had been able to integrate their online transactions if they're a retailer, or their online banking activity if they're a bank, and across the board, so they'd have one view of their customers' sales activities or money transfer and deposit activities across channel. And that had huge value, right? And it's proven to have huge value, cross channel sales analysis. But let's take a retail example. From an information perspective, what's different about an online transaction from a regular transaction via catalog, call center, or store? The answer is very little. It's still a product at a price to a person at a point in time with a given discount level. The only thing that's different informationally is that the location ID or channel ID has a different value. So maybe we add channel ID 5 for internet on top of the original 4 that we had. That still adds huge value, even though the information is really 99% the same. There's just a new way to capture the same information. Where you get into exciting things with big data, it's because it's often 100% new information. So the extension here is go to the web browsing history behind each of those sales. Now we suddenly have information on exactly how did somebody decide to make that purchase through that channel. We now know, do they care more about the features or the brand? Do they care more about what customer reviews say, or do they care more about what our technical specifications say, or our shipping deals and so forth? That information was effectively not available previously, maybe on a small scale with a survey or a focus group and so forth, but very small scale, very expensive. Now you have millions of people's worth of that data, and that fundamentally changes the type and breadth of analysis that you can do. And if you look across all the big data sources that people get excited about, I think what you're going to find is the reason it's so exciting is because virtually every one of them has some aspect or is completely, entirely new information that can address old business problems in new ways, as well as entirely new problems that we didn't have any way to address before. And that's why it's going to be a very real and impactful trend moving forward. This is when you get into new information. This is a key thing that I would encourage everybody to remember, especially those of you who are going to be practitioners. New information will beat a new and improved algorithm every single time, meaning you spend a lot of time in your career taking the same problem with the same data set and finding, I'll create this new metric, I'll do this new transformation, I'll try this new modeling methodology to get a little extra lift out of a model, for example. And that can be successful, right? And that's how we all keep employees, because we're always able to squeeze that little bit out. But I would argue that as soon as you have access to new information, let's say the first time the web data becomes available to you, drop all of your work at improving the existing model, even take a crude version of the new information and toss it into that process, and I'll bet you're going to get a huge lift. So when you have an opportunity to get new information, make it your first priority. Do everything you can to test whether that information is going to give you lift, because you can get massive lifts, and we see it all the time, where you add the new information and you suddenly are massively increasing the power of the analytics. And again, it makes common sense when you think about it. More information should make the analytics better. But people sometimes fail to quit focusing on the incremental improvements they were already in the middle of, rather than going for the potential quantum leap type improvements. And then just to give you an example of how entire industries are being shaken up, you know, the way you've invested in and assessed advertising investments in general for years was done in what I consider very rough-cut ways. Given the billions of dollars spent on advertising, it's ridiculous how unmeasurable it's always been. So way back when I was doing marketing mix models and including advertising, we'd get these gross rating points, which Nielsen, for example, would have a couple thousand people around the country. Maybe they had 100 here in Atlanta. And they'd monitor what those people did, and they'd say, well, 10% of our 100 households appear to have watched that show, therefore that must mean 10% of the 7 or 5 million people around Atlanta did, so you have this many rating points. And we'd put that in, and we'd have a little decay function over time, because people would see an ad, and again, back in the days when I first started this, there wasn't an internet yet, so you'd have to literally go to the store to act on this anyway, give people a day, a couple days, maybe to the next weekend, so you'd have this decay curve. And the analysis I always thought was very, I call it squishy. It wasn't that it was necessarily completely bogus, but I always suspected it was as much bogus as not. And it was an incredibly inefficient way to analyze it. Well, now, we suddenly have, if you didn't know it, your cable and satellite provider tracking every single time you press a button on your remote. They know when you hit pause, they know when you fast forward through an ad, they know exactly what shows you watch and in what order. This is fundamentally new information. And so one of the customers we worked with then was looking for ways to better attract advertisers and get new revenue streams from advertisers. And the funny thing is, it can work out good for both. So here's the scenario. There was I think it was Ultimate Fighting Championship, one of those fighting-oriented pay-per-view shows that they wanted to study. And what we did was go in and help them look at what were the shows that were being watched just prior to this. And so they had been investing heavily in advertising where you'd expect. ESPN, maybe Spike Network, all the places where you might have especially young guys who are pretty macho in their attitude watching TV. That's where they're advertising. But what we found was that there was actually a huge crossover coming from the History Channel. That doesn't make a lot of sense. You don't think of the typical History Channel show. You go, well, why would people come from History Channel to Ultimate Fighting? That completely breaks the demographic mold. And if you go look at the History Channel's lineup, I guarantee you almost every show you'll go, this makes no sense that people want to come from some very educational history show to Ultimate Fighting. But here's what it was. How many people have ever heard of or seen Swamp People? Anybody? Yes? Okay. So if you haven't, you got to check it out once. This is my buddy Troy. I call him my buddy because I feel like I know him, right? These are these Louisiana bayou alligator hunters who go out and literally hunt and wrestle these huge, up to 14-foot alligators, okay? Not at all your typical show. And my wife won't even let me watch it around because she thinks it's so stupid. She makes me watch it, other times. I've never been able to convince her to take it seriously at all. The thing about Swamp People I've always found intriguing is that it makes me feel not very manly because these guys are so much more manly than me doing this, right? But then I'm also simultaneously proud to be a man because there are manly men like these guys, okay? So that's the appeal of the show to me, at least. But anyway, point is, now it suddenly makes sense. Of course, that does make sense that these young macho type guys would love that show and they want to come to Ultimate Fighting. So if you're the Ultimate Fight promoter, what do you think is going to be a better price point for advertising? The ESPN evening major sporting event or Swamp People rerun on History Channel? I promise you, you're going to get a much lower price and then you can measure the bang for your buck. So this is the kind of thing that's happening where even how advertising gets assessed and how you decide where to invest is going to be fundamentally changed in the next few years because this data is becoming broadly available. So we have our first audience participation. I call it Pick a Rant. So here are the rules. I'm going to show you 3 topics. There's 3 questions. And Andy, you'll have to be my impartial judge as to which one wins, okay? So it's sort of like the people that certify Miss America or whatever, okay? And the rules are this. We will vote. You will pick one rant and only one rant. The 2 rants that you do not choose are forever gone, and you will never have a chance to hear me speak of them again. So choose wisely. It's a very important decision. So, your 3 choices are, start with the right perspective, is the big data analysis process different, and my data is bigger than your data. So give it a thought, and then we'll do some hands, and Andy will help me count. So, how many people would like to hear a rant on start with the right perspective? Right? You got a general guesstimate? All right, what about, is the big data analysis process different? Everyone is only voting for one, right? Okay. Because that's a lot of hands both times. Okay, my data is bigger than your data. All right, I think my data is bigger than your data definitely lost. Do you have a feel for between the other 2? I think number 1 had it? Okay, it's been officially certified. So, let's start with the right perspective. Here's the interesting thing among the hype of big data, and this is actually, unfortunately, a massive trend that is still carrying on, which is even some of the most disciplined large companies we work with who are very smart with their investments, at times you might say very stingy, okay? They are going full speed into big data initiatives with no business problem, no plan, buying technology left and right, capturing data, and then you're like, well, what are you doing? What are you planning to do? Well, what do you mean? Well, we got to get into big data. They're doing it totally wrong. You've got to start with the business problem first. You've got to start with some idea of what the heck you're going to do, or you're just throwing money down the drain. It's silly. And these companies would never do this, and it puzzled me like crazy for about 6 to 9 months. I'm like, why are they doing this? And I'd meet with another big customer, and then we discuss what they were doing, and then I'd go, okay, but why are you doing this? And they'd always have that same answer. Well, we're going to figure that out, but we know we got to do something. And I figured out the problem finally. It's that every board of directors is asking every CEO, what are you doing in big data? The CEO turns around to the CIO, the chief marketing officer, what are we doing in big data? And they pass it down. The only acceptable answer, given the hype today, is we're on it, we're on top of it, we're spending, we're making it happen, right? The answer of, give me another quarter or so to really figure it out and plan it out and make sure we spend wisely and then we'll start, is not actually acceptable. So everyone goes headlong knowing full well that they're breaking their usual rule of starting with a business proposition. And it works great this year or last year. But then 12 months, 18 months, and we're starting to get to that point now where we're going to see this hammering a lot of people. The question is going to be asked, well, now you've spent that couple $1 million and you've spent this year and a half, what do we have to show for it? And then a lot of them are going to have to say, well, we're still looking for what we're going to show for it, and they're going to look pretty bad. And I think there's going to be some jobs lost over that. So it's a shame. But you've got to always remember, no matter how bad the hype is, if you don't know how you're going to use that data, don't know how you're going to use that technology, I would suggest you pause and figure that out before you go headlong into it. So let's talk about some of the people aspects a little bit. So when I started in my career, there actually was no career path for analytic professionals. That's my blanket term for people who do analytics. Today, there's data miners, machine learning experts, there's data scientists, all kinds of terms. Analytic professional, that's my umbrella. There was no job or career path for a person like me. You would go to a company if you went into business. Now, there was a career path if you wanted to go into academia, for example, or even in government, like Census Bureau, Fisheries, Wildlife. They were hiring most of the classmates I had. The few of us, I'd say 10% of us back when I came out, actually went into business. There wasn't much of a career path. So we were pretty much these nerds in the corner that people, they thought it was okay to have us around, but we weren't really part of the business team. We weren't part of the IT team. We were sort of these freaky nerds that seemed to have something to add now and then. And I always say that we would, talk to somebody who would talk to somebody who would talk to somebody who would possibly make a decision at one point, right? Very far removed from the actual action. What's amazing today now is you have analytics people at minimum sitting next to decision makers, if not being a decision maker. And that is a massive trend that has only accelerated in the last few years. The number of organizations that have gone not just to at least a VP of analytics, but are elevating up to even a chief analytics officer, it's amazing. Most of the big banks have them now. A lot of the other organizations we work with are starting to ramp that up as well. Now, before I move on, I just have to ask, because some of the people here are a little bit younger, does everybody here recognize this is a Revenge of the Nerds picture? Everyone? Okay. I was at a university speaking once, and I had a question that shook me a little bit, because after it, somebody asked in the audience, Bill, that picture of you and your buddy from grad school, okay? I didn't really hear the rest of the question there, because I'm like, oh my God. So I just want to make clear, this is Revenge of the Nerds. I'm a stats master's degree. I can't claim that I'm not geeky by definition, but I was never that bad, okay? And I just like to put that disclaimer on now, because I was like, wow, some of these young folks actually have no clue who that was, and I guess from a distance it could look a little bit like me. But anyway, so we've gone from no career path to this. Suddenly, analytics, big data, all of these things are not only hot and in demand, and salaries are rising, it's being called sexy by very legitimate organizations, okay? My wife doesn't yet believe this. I can't sell her on the fact that I should be more sexy to her now because I'm in fact an analytics person. She doesn't want me to claim to her friends that in fact this is a fact, but she'll come around eventually, I'm confident. Key is two things. This is awesome for all of us in the room who care about this space, and there's, the job opportunities. Look, Andy just took a new job, Travis just took a new job, everybody's getting phone calls. It's an amazing place to be right now. The caution I would give is, how much upside is there from being one of the most in-demand, fastest rising salaries, considered sexy jobs? There's not much upside from there, right? So you've got to expect that eventually it'll level off. I think we've got a long career in front of us, but enjoy this sort of spotlight of being the hot, cool thing while it lasts. So I give everybody a homework assignment. How many people here are what you would term yourself an analytic professional? You focus primarily on analytics for your job. Most people. Those of you who don't, I'm sure know someone or you wouldn't be here. So, the exercise is this. When you're getting ready for bed tonight or up in the morning tomorrow, then you take a minute and you just stop and look in the mirror and you smile at yourself and say, I do analytics and I'm sexy. Okay? And if your wife or your roommate or whoever catches you and goes, what the heck are you doing? Say, no, it's true. Bill told me to do it, and it's actually true. So one of the challenges then for people is that when I came out of school, I'm overgeneralizing, but most analytics at big companies fell into these two broad classes. I'll say forecasting and statistics. It was your classic A/B test, which campaign worked better, maybe a regression for churn or decision tree, or forecast, your classic time series, how many sales coming up. Most analytics companies, what we're actually doing, fell in these two categories. You could hire a smart person out of school. They could do probably all of your analytics or very close to it. Hiring was therefore pretty easy. Hey, let's go find another smart person, add them to the team, and we'll just assign them to whatever projects come. Back to the point about the differentness of the data, we've moved so far beyond this now that it's shocking. I mean, everything from graph analysis, voice analytics, geospatial, text. It's impossible to find somebody who's an expert in all these anymore, right? So, for example, myself, text analytics, I'm not a text analytics expert at all. I've, in fact, never used a text analytics tool. I never have done that in my background. Could I, if you sat one in front of me, learn it pretty quick and be productive? Probably, but it's going to take me some ramp up. But you're not going to want to pay me to learn all of those things over time, and probably I wouldn't be that good at any of them. So it changes the entire paradigm now as you think about how you build your organization, almost to like a zone defense. So you're not going to have anybody that knows all of these, so now you have to start to think about hiring differently. Instead of just saying everybody's interchangeable, you got to make this pie, conceptually, with all the kind of analytics you need to support as an organization. And then you have to hire people to make sure that combined, they cover everything. And if your geospatial expert quits, then you better have your primary criteria for the replacement be geospatial. And whatever other skills they have is just bonus. They'll have others, but the point is you need geospatial. You can no longer expect that you just hire a smart person and they handle all of it. And this is a big change. Luckily, this change is happening concurrently with teams getting larger and analytics getting deeper so that you can spread this out. If we had had that variety of analytics early in my career when a large analytics team was 10 people, I mean a very large team was 10 people, we would have been in big, big trouble. Now, when you're up to teams, or some of these banks have hundreds of people, right? It's much easier to do this, but it's definitely a shift, and even at Teradata the last 10, 11 years, we're hiring differently than we used to hire, absolutely. So I want to cover one thing that I think is an interesting point, which is this idea that all big data is unstructured and that structured data analysis is somehow passé. And I would argue that there is such thing as unstructured data, and there are some things that you do with unstructured data. But the question that you've actually been asked and the way that you actually answer that question, virtually 100% of the time, will be based on structured information. And what I mean by that is take this image, 100% unstructured. Maybe it's a 5 megabyte image, and maybe there's millions of those, say in a FBI database, right, of crime shots or something. When they have a picture of a suspect, they don't literally match up the pictures somehow and decide, does this picture match that picture? What they do, they run facial algorithms that will pick out all of these various markers on a face, and it conceptually makes this little polygon. Here's the key. That polygon is both fully structured and it's also trivially small in size in terms of the information you need to define that is very small relative to this 5 megabyte image. So at the end of the day, your question was, does this person match our database? You start with images, you reduce the images to the structured information, then you join or match on that structured information to answer your actual question. And that's an important point. Same thing happens with text. You can't do a sentiment trend, or you can't do a trend on how many people are mentioning a given product and so forth directly from text. What you do, you run some text analytics and you extract key things, right? Who said it and when, and did they or didn't they mention certain things? What was the sentiment? And what you effectively end up with, like in sentiment, maybe you have a 0, 1, yes, no, it was positive. Maybe you have a scale of 0 to 100. Whatever your case may be, you're back to numerical information. Guess what that numerical information feeds? Things like a trend line. Things like, can I predict churn or likelihood to buy based on this additional information? So the text is reduced to structured data that's then actually input to the analysis. So a lot of the unstructured techniques like natural language processing can be thought of more as a sophisticated ETL or transformation process to prepare data for an analysis. And that's certainly far more complicated than when you started with financial data and simply, did a little cleanup and data quality work. It's much more complicated to do this than to do that other stuff. But at the end of the day, it's still the pre-processing step to get you to the data that you actually need to answer your question. And so from that angle, I think you don't have to be as intimidated by the idea of all this unstructured images and text and other things flowing around there, because as long as you have someone who can translate that into the important pieces, you're off and running with many of the classic standard tools and techniques that you've always used to analyze data. All right, so we got another pick a rant here. And Andy, are you prepared to, okay? So here are our three choices. Analytic professionals are just a bunch of cowboys. If we give them more access, we'll lose control, and nothing but all stars for us. So who wants a rant on analytic professionals are just a bunch of cowboys? Couple. Who wants to hear if we give them more access, we'll lose control? And who wants to hear nothing but all stars? That's what I was thinking as well. All right, is that certified, sir? Yes. Okay. So the other two have disappeared. We'll talk about number two, and I love this one because this is one of the fallacies that I hear as an objection from IT departments as to why they shouldn't allow people who need to do analysis to have more freedom on the systems where the data resides. They'll say something about, well, we let them on here, we're not sure what they're doing, somehow there's a big risk in this. And I always say, you got to realize how foolish that sounds to me from this perspective. I'm nicer than what I'm just doing here. I don't actually word it this way to them, but this is what I'm thinking as I say it much more politically correct. It's like, you got to remember, Donald Rumsfeld had the classic quote about how there are unknown unknowns and known unknowns. Like there are times you know that you don't know something, and other times you don't even have a clue that you don't know something. Unknown unknowns are far worse. What you have in an organization where IT hasn't opened up the systems is exactly where I grew up, where the analytical team builds their own system over here, a bunch of servers, where we take all the data from those systems and bring it over here and do whatever the heck we want. In other words, they've already lost control. In fact, they've lost it worse. They have an unknown unknown. They have no idea even what we're doing or how they don't understand it. Versus, if they let us onto their system, they may not know what we're doing, but at least they have an ability to get some visibility and some understanding over time. And I would argue, much less risk to the organization, and they can start to adapt their system and make it more effective and efficient. Everybody can win. So the idea, it's like putting your head in the sand. Well, if they're over on their own system, somehow it's not my responsibility. That's silly. So absolutely, you've already lost control. I'd rather you try and get it under control and loosen up. There's that rant. Sorry about that. If there's anyone in IT here, I apologize. I beat up on everybody equally at times. So let's talk about a huge trend we have these days, which again, I think is really something that's been going on for years, but it's getting new focus, which is the need to focus on discovery analytics in addition to confirmatory analytics. Again, folks like me have been doing conceptual discovery for many, many years. The difference is that we were doing discovery on data that was already pretty much known. Like we had a decade to work with transactional information, right? So it didn't take as much of a stretch. Here's the difference. Confirmatory analysis is the classic thing where it's in a company, it's very easy to get it approved. I can come in and tell you, I'm going to do this, it's going to take me this long, I'm going to build this churn model using these metrics. At the end of the day, we'll see how well it works. We don't know if it's going to work or not till I'm done, but we know how we'll measure if it works or not, and we also know exactly how long it'll take me to get to the point that we know. Easy to get that approved. It seems risk-free. Discovery analysis is much more broad. You don't have a full scope defined yet. You're not even sure what the right answer is yet because you haven't had a chance to even understand the data. You suddenly have web data for the first time. You don't know how you can apply that. You have sensor data for the first time. You need time to literally go in and dig through and find out what problems it can address. So a confirmatory analysis with machine data, let's say you have an engine monitoring system. It would be, confirmatory would be, hey Bill, we want you to see if the temperature reading can be used to predict an imminent overheat of the engine, for example, a trivial example. Because we know exactly what measurement to take and exactly what to correlate it with and so forth, I could still pretty tightly scope that problem. A discovery analysis would be, Bill, we have all this sensor data in the engine. See if there's anything we can predict. You've left open what metrics, which sensors, what am I predicting? I can't even tell you how to measure it because I don't even know what I found. This is very uncomfortable for people because it seems risky, but it shouldn't be. In fact, think about, I take an analysis, an analogy. A lot of industries follow this very much. Think about oil drilling. The discovery analysis is when they're analyzing all these different locations that they could drill to figure out where might we drill. They have no clue till they've done all these assessments. The confirmatory analysis is now we think that this is the place to drill, go drill, and you either find oil or you don't. Same thing, discovery analysis will lead to confirmatory. Hey, I think I found this pattern in the data that will predict an overheat. Now we're going to go do more confirmatory analysis to prove that it really does work, and then we can operationalize that. But to do this, you actually now have to invest differently, and this is something that companies have not started to do as much as they need to, which is you have to start to fund portfolios instead of projects. An individual discovery project will be very unpopular all the way up the chain because it feels so risky. I can't guarantee you success. I can't even guarantee you the cost. So what you have to do is think about it like retirement planning versus venture capital. In retirement planning, you invest carefully, you invest to minimize volatility and so forth. Whereas venture capital, these people go and they put down a bunch of money, fully expecting 8 or 9 out of 10 are going to go belly up, and they hope the other 1 or 2 will more than pay for it. It's just a different model. The huge risk you have, both in investing your money and in investing in analytics, is this. If you're too safe, you have actually a huge risk that you don't even recognize. If you were to today put all your retirement in government bonds yielding 0.5% or 1%, you would have a virtually 100% chance of never losing a penny, and in fact having a little more money in your balance every single year. You would also have a virtually 100% chance of being destitute at retirement because you're not even keeping up with inflation. You're actually losing spending power every year. So you're simultaneously guaranteed not to lose while simultaneously guaranteed to fail in the goal of retirement. Same thing with investing in analytics. If you play it safe all the time, you're guaranteed that you'll continue to get your single hits and that you'll continue to feel like you're making progress, but you're also guaranteed your competitors are going to leapfrog you and probably take you down over time. And the way to think about this, again, it's not too crazy. Imagine this. Baseball, we're finishing the World Series up here. Best hitters in the world are 30% maybe, right? No one in their right mind goes, okay, it's the game 6, we're down by a run, Bill, you're my top hitter. You go in there, and if you don't get a hit on this at-bat, you're fired. You're benched, you're done. No one does that. What they say is, you know what? Over the course of the season or over the course of the playoffs, the last X many games, you've had a pattern. I trust you to try it, but any given time, there's a 2 out of 3 chance or better that I'm going to miss, and you accept that. This is all we're asking you to do when you invest in a portfolio of analytics. It's about investing, give me 6 months and 10 projects. At the end of the 6 months and the 10 projects, I better have had a return. But you don't care which of those had the return. If people can get over that, it's a lot better spot to be. So I want to bring you to an example that really seems to resonate with a lot of people, that ties a couple of these themes together. And it gets into enabling the people to do analytics and having IT start to enable rather than try and serve and control. And the analogy is based on the yogurt industry. So if you stick with me for a minute, I'll bring it all back and it'll make really good sense, but I got to give you some background. So it's a true story that about 2 years ago, I live over in Marietta. There was about 2 miles from my house, an old school, as I call it, yogurt shop, where you walk in and the person would say, what would you like? And if I say a medium chocolate, then they'll give me a medium chocolate, and then they'll say, what toppings do you want? If I want a topping, they'll put it on, and then they ring me up. The server prepares it, and I pay by the cup and the topping. The problem with that was that I never went very often. They didn't have all that many flavors, and the toppings, it was $3.50 for the cup and then $0.95 for a topping. I found the topping price outrageous, especially for like a 2 cents worth of sprinkles. I would get at most 1 topping, probably none, never very happy. Didn't go very often. Then 2 years ago, within a quarter mile of that first location, within 6 months of each other, 3 of the new style yogurt shops opened up, and 6 months later, the first one was out of business. This is this new style shop. We have them all over Atlanta now. They got a whole wall of flavors, this whole bar of toppings. You go do whatever you want in this cup. They always start you with a massive cup. They don't start you with a small cup, right? And then after you prepare it, you pay by the ounce. Here's the key. I go to this place. I grab a little of this flavor, a little of that flavor. I can't help but put a little bit of this other flavor. Then I see the toppings. I'm having this. I'm having that. I'm so excited that I'm not getting ripped off for 89 cents. I add a little bit more. And I weigh that daggone thing. And I pay $6.57 every time. Okay? And I'm happy to pay the $657. In fact, I'm thrilled. I like to take my kids there now. So here's the key. That's the holy grail in retail. You have just gotten me to visit more often, spend almost double per visit, and be more happy. You don't have a better winning formula in the retail industry. So let's think about the cost model. If you were to open up a shop, the cost model is almost identical. In fact, the new ones you could argue are a little higher because they have more machines and toppings, but let's just take that piece out. You have one machine per flavor, same exact storefront, same exact cashier, same exact point of sale system, chairs and tables, everything's the same. The cost is almost the same to run these two. Yet, by simply tweaking how you prepare and pay, one model is able to generate massively more revenue and more satisfied customers. That's a pretty big win. Furthermore, if you were to say, I own one of these, I'm getting crushed by the new ones, you don't have to tear down your whole business and open a new store. All you'd have to do is move your cash register 5 feet over out of the front of the yogurt machines and take the little shield that's on the customer side of the toppings and move it to the cashier side of the toppings and let them have at it and put a little scale there. Very small investment to transfer. So how does this all relate to our topic at hand? I will propose that this is the classic IT model where they determine what data you should have and what portions, and you may order it and you pay for it. The toppings are like the tools. You could have any tool you want theoretically. It's very difficult and expensive and a hassle to get new ones approved. You make do with whatever you've got, and you just sort of grin and bear it. You're never really that satisfied. You're always a little grumbly about the value you're getting from IT. This is the discovery model we're talking about. And it no more requires ripping out your technology than does the store. You know, for example, when people have a Teradata system, we've got ways to just configure sandboxes and discovery environments that enable users to have much more freedom without having to replace the things. It's about policies and settings. It has nothing to do with the technology itself. It's a very easy transition to make. And here's a couple of really cool things about this. If you loosen this up, users will get more value. Business people will be more excited. They can use different tools as they discover. When we go into production, you're going to have to still do it right. But we can have that freedom. When it comes time to budget, guess what? We're going to be a lot happier about ponying up whatever funding you wanted because now we're suddenly getting more value. It's a win-win all the way around. And I had a great question asked last week at our conference from somebody from a large bank when I was presenting to them at lunch. One gentleman says, well, Bill, you know, what about somebody walks in and then turns on the machine and leaves it and it's just spewing out all my yogurt and it's costing me a fortune? I said, well, hold on. It's not that this is unattended any more than your analytics environment would be unattended. There's a cashier sitting right there. If she sees I've walked away from the machine and it's spewing out yogurt, she'll just walk over and flip it back off, right? Maybe you lose an ounce or two of yogurt. I said, you see me doing it repeatedly, you're going to kick me out of the store. Same thing here. I start doing things that are bad, you can just take away my permissions. It's not unpoliced, it's simply policed differently. And when you get into operationalizing then, this is an interesting one. It was actually a customer here in Atlanta recently that spurred this specific thought in my head. It's about who owns the process. A lot of IT companies are very concerned, organizations and companies are concerned because once something's in production, they own it. And this person was telling me, the VP and their team was saying, you know, we're really nervous because we have all these new analytics coming into production. We don't really understand these processes, and then they break, and now we're on the hook, and we're spending all kinds of money, we're getting beat up. And I said, well, wait a minute. To me, you have a problem with the contract you have with the business and the analytics team. If I put an analytic process that I build into production, I would expect that you would own making sure the systems are up, it's submitted on time, that the resources are available for it to complete, and that you validated everything seems to have run okay, and if there's a problem, you contact me. If the logic itself breaks somehow, if there was a flaw in the logic, there's no way that IT should be responsible for that. That should be the analytics people who built it. That just makes common sense. I don't think hardly any analytics people out there in the industry would argue with what I just said, but they've never been asked to do that. They've been offered the opportunity to throw it over the wall to IT and forget about it. Who wouldn't take that deal? That's a great deal for me, right? But it's a bad deal for the company. And it's actually a bad deal for me on the back end because my analytics don't have maximum power now when if they break, they won't get fixed. Everyone gets frustrated. Everyone questions whether analytics, quote, can work for us at this company. If you just change a few of these things, everybody will be better off. Let's go to our last pick a rant then. 3 choices. Choose wisely. Anyone can do analytics. An analytics degree or certification is all we need, and don't waste time on fluffy stuff. So who votes? You prepared, sir. All right. Anyone can do analytics. Okay? An analytics degree or certification is all we need. Okay? Don't waste time on fluffy stuff. A little tight. Should we do 1 and 3 only again? All right, so this is a tiebreaker, our first tiebreaker round, folks. This is exciting, isn't it? So anyone can do analytics. All right. Then let's see that don't waste time on fluffy stuff. What do you think, Andy? All right. A judge is audible? Anyone can do it. Okay. We can only have one. You guys want to have a little fight here real quick? A little bit of fight? Can we flip a coin? I think he's the official judge. All you can do, complain to the judging organization after the event, okay? Well, that's against the rules of Pick-a-Rant. Maybe later, we'll see. So anyone can do it. Like, here's one of the things I found that I think is a little bit funny, which is, you ever heard the thing, sometimes people who, on the extreme, people who are incompetent sometimes don't even realize they're incompetent because they don't know enough to know it, right? The less you understand something, the more you tend to underestimate how hard that thing will be. And anyone who has kids who get some toy for their kid that comes with instructions to assemble sometimes, you have no idea until you get all those pieces out and you realize even with these instructions, it's going to take me 3 hours, okay? So here's where we go with this. If I were to come to you and say, or if I went to my marketing department and said, you know what, guys, I'm tired of analytics. I want to be a creative person now. I want to develop creative. And you know what? I have taken every class there is on Adobe Photoshop because I know that's what you use. I know how to add images and text. I know how to send it to a printer, a professional quality printer, all of this. I'm ready to do your creative. They're going to look at me and go, are you crazy, Bill? You don't have any training to do development of collateral like that. I'm not going to let you do that, right? If I went to our finance team and said, I know what software we use to close the books, I've studied that software, I know exactly what menu options I have to pick each month in order to run through the process, please let me come and help close the books. They're going to say, are you crazy? You're not going to do it. And if I were to say, I have this new chainsaw, and I know your tree just fell, and I've read the manual, let's go chop that tree up, right? You better go running the other way and say, you're not coming near my tree, okay? Yet, somehow, I have seen more than one time where people will go, we got this cool analytic tool, we've had these business people that have no training, they've sort of read the manual and had a class, they're ready to do our analytics. We don't need to pay for these fancy smancy analyst people. Our marketing guy, Bob, in marketing can do it now because he has a tool and he took the training. It's outrageous, it's no different. Yet, that last example, many people actually pursue. And I think it's mainly because people understand how silly it would be to cut down a tree or close the books or do creative because they understand that much deeper. A lot of people, they don't understand the analytics and therefore they make that crazy fallacy. So where are we heading now? I think that, and this is what my new book is about, the analytics is going through really an industrial revolution. And what I mean by that is that in the old days, if you needed a pot, a cup, anything, you would go to a potter who would hand make it, right? They could make you beautiful pieces, customized pieces, exactly what you wanted, but it wasn't very scalable or inexpensive, right? The Industrial Revolution let us start to have mass production of items. You can now go to a store and there's hundreds of plates that are the same at a very cheap price and a very consistent quality. Now, are they as pretty and customized and beautiful as the handmade piece? No, right? Are they even the same quality? Yeah, maybe not, depends, but you're willing to give up some beauty and some customization to have a consistent quality at a cheap price, knowing that if you dropped a plate, you could easily replace it for $2 in a trip to the store. This is what we have to do for analytics because almost every analytic I've ever built in my career has been like this. Most companies do analytics like that. You have these master artists who are the analytic professionals who put extra love and care into creating the best possible analysis and model for every situation. And that still makes perfect sense for very high value problems. Just like I still have custom pottery in my house. We have a piece on our dining room table, we have a piece a couple other places. For places where it has high value, but to have breakfast in the morning, I don't need a custom piece of pottery. I just need something that works. This is what we have to start to do to increase the breadth of analytics. We have to start to industrialize what we figure out and automate it in a way that we can stamp it out again and again. So a very tangible example of this, and this is something I've seen a number of companies migrate from, which is, in the early days, we might have, say, a propensity model for the top 10 to 20 products that a company carried. The other 190, let's say they had 200 products, they wouldn't have any model for it. They couldn't afford it. But if you build those 10 models and you understand the commonalities that led to those predictions, you can in a somewhat automated fashion create a process to run very similar models for the other 190. And those other 190 now have something available to get a better result than if you didn't have a model at all. This is the key. These operational analytics are building on the traditional analytics. It doesn't replace our traditional batch. It adds and takes it further. You still have to, as an industrial scenario, come up with the idea. You have to sort of draw it out on paper first. You've got to build a prototype and test it. Then you've got to see if it'll actually create the analytics you want on a regular basis. Then you can industrialize it. So you have to take everything you've already done and now take it even a step further. And what you're doing is you're first embedding the analytics into a business process. This is about literally embedding it. And this is one of the exciting changes the last few years. The data and analytic platforms now have the analytics embedded within them more and more, so that it's no longer I have my data platform, I have my analytic tool sets. They're becoming merged into being one and the same. They're automated. I turn this thing on, it's going to run on an ongoing basis, maybe millions of times a day for every website visitor, or for every time that we have to give the call center an update, or for every time we have to decide which of the equipment out there might need to be taken out of service. And they're prescriptive now. They're not just predicting what might happen, they're coming back and also saying, here's what we should do as a result. That happens in what I call decision time. People get way too hung up on real time. Real time is needed sometimes. Vast majority, it's not. If your decision needs to be made in an hour or in a day or a week, all you need is the analytics to run in that time. It's silly to waste time engineering a process to run in seconds if, in fact, you have hours. If I need a decision by end of day, that's fine. But the most important thing with operational analytics is that they are taking the action. They're not just prescribing what should be done, they're making it happen. You have the most common example you'd see day to day right now is you're on a website, the operational analytics are running an optimization as you hit next and coming up with the ads you should have and then displaying those ads. There's no longer somebody approving what you see before you see it. I spent years having my list pools for mailings approved. It's now just done, and now you see what happened. And so it's important to understand that when you talk about decision time operational analytics, this is not just saying applying your batch analytics operationally. I wish there was better terms for this even, because people get confused. Sure, there have been analytics applied operationally for many years. That'll continue. Operational analytics are a little bit different. I'll give you an example. One of the studies we've done with a financial institution, and I believe this has happened with telco as well, we've done this, is around what causes people to churn from their interactions. And one of the trends was if they complain about a fee multiple times, then their risk starts to go up a lot. And maybe after the third complaint, you better refund the fee if they're profitable. So here's the deal. Classic batch analytics that run nightly, here's what would happen. I'm on the website, I see the fee, I send in a quick note from the website directly, reverse it. I get an email back, no. So the next day on the way to work, that night the models are updated and it says, if Bill asks again, no dice. So I call on my way to work. I ask for it and the call center agent sees correctly not to do it. She goes, sorry, sir, I can't do that. Okay. So I'm really mad now. I pull into the branch I'm about to drive by, go into the branch manager. Guess what happens? That model hasn't been run yet, has it? He sees that he's supposed to reject it, so he rejects it and then I close my account. That's traditional analytics applied to an operational problem. Operational analytics are when, as soon as I've called that call center rep, that phone call gets logged, my model is rerun for me, and now it's flagged in the system, give Bill that refund, so that 2 minutes later, when I walk into that office branch, the manager sees, I better give Bill that refund because he's valuable. That's the key here. It's about having it take the action and make it occur when it needs to be. And so there's a couple things about governing it that get to be difficult. First of all, it's about improving and not perfecting, and this is incredibly hard for analytical people like me to accept and deal with. I am used to building the best possible model. If you can get more lift, you always want to get more lift. That's not the point here. This is about getting from here to here and being happy, because you can't afford to do all the extra work to get here. It's increasing the breadth of analysts. Take down the lift you can and worry later about if there's an effective way to get more. You also are in a point of monitoring versus approving decisions. You don't have a VP of marketing approving the offer distribution and the list pools. You have the VP of marketing seeing, here's what's gone out in the last hour. Does that look okay? And back to the manufacturing paradigm. You could have a classic control chart kind of scenario. In a manufacturing line, there might be the temperature of the items that come out of an oven, for example. As long as it's within spec, the line keeps working. Well, you see the distribution of offers. As long as it looks pretty much what expected, you let it keep going. But at some point, they go, wait a minute, why are we doubling up on offer number 2 all of a sudden? Hit the stop button. Hey, Bill, you better check something. Something's going wacky in your process. And last, you can expect things will go wrong at times, as with any automated process. No assembly line is perfect. Any assembly line in the world that you go to has defective product come out. It's just the matter of keeping it small enough. You have to accept that. So things can and will go wrong 100%. You cannot let that derail yourself. You can't sit and go, oh my gosh, our spam algorithms, we got to throw them out because we got 5 or 10 spams for each of our employees through today. Well, without the spam algorithm, would 905 have gotten through? You'd be silly to get rid of it. The worst example of this would be the flash crash in 2010, where automated trading program went amok, and then other ones followed it, and you had mayhem on the market. Well, did all the program traders go out of business that day? No. In fact, program trading is stronger than ever, because if you keep the error rates low enough, it's just the cost of doing business. You certainly want to have checks to avoid another catastrophic thing like the flash crash, but even the flash crash didn't cause enough damage to make it unprofitable to continue to do those analytics. So you have to prepare the organization to accept that at times things might go wrong, and as best as you can, you have processes in place to react quickly. And then just to sort of finish up on a thought or two, a lot of truly operationalized analytics today aren't really that complex yet. Just like analytics in general weren't very complex when I started in my career. But they're going to get more complex. So if you think about the car example, cars now have things like automated braking. That's pretty easy. You've got a sensor, it sees how fast you're going and where the thing in front of you is, and it'll hit the brakes if it realizes you're not going to have time to stop. The data and the analytics there are pretty simple. But it's getting further now where you have things like the driverless cars that are coming to a world near us very, very soon. These things, imagine the sophisticated analytics that have to happen. Anyone who is from here who drives at 400 where they're doing the construction in Buckhead and it goes under the tunnel, a couple times coming back from the airport, especially at night and when it was rainy, literally, simultaneously, I could see the old lines where they sort of scraped it out. You could see the scrape out point. I could see where they had overpainted the other temporary lines, and then you could sort of see the new straight lines they wanted you to follow. But at night, they all sort of showed up equally shiny in the light. I had no idea where the lane was. A number of times, I'm just driving, and there was no one around me, so it didn't really matter, right? And when there were people, we would tend to just follow each other, but very dangerous. Imagine this, though. The Google cars, they have to sit, monitor video in real time, analyze which of these lines is most probably the right one and steer you in milliseconds. It's massive analytics, a lot of these things. And the thing is, as these get more sophisticated, I like to say that my children today, who are in elementary school, will 100% learn how to drive. By the time they're my age, they probably won't have to drive. They'll probably have the option of driving. Driverless cars will be pretty ubiquitous. By the time they have kids, those kids probably won't be allowed to drive. It's a safety thing, right? It's true. It's so much safer to have these cars drive themselves and interact with each other and keep the speed constant and everything that it'll be illegal for you to take control of your car unless you're on a very rural road with nobody else around. It's just like how seatbelt laws and everything have evolved. So that's all analytics, though. If you think about this, and there's examples all around where things that people in the general population won't even give a thought to as having anything to do with data and analytics are actually 100% data and analytics. And that's why all of us have a lot of career stability the next few years. And so one other example I'll give you, or two other quick examples, is that, covered that one before my slide. There's the slide about not being able to drive. Got ahead of myself. This is a true one too. So a large retail customer, they have the classic thing, you've all been to the grocery store, suddenly there's a run. Maybe like tonight, for example, there's an event here. And there's a store right down the road. They don't know there's an event here, but 10 of us or 20 of us decide to run by the store and buy some stuff. Then there's this run at the cash register, a big line forms, the manager pulls somebody over, they open another lane, we're all fired up, and then that employee probably got pulled off of something they're in the middle of to go and staff the lane. Someone had a really smart idea, which was, we've got these security cameras. We can monitor the parking lot and sort of see how full it is. If we see an influx of cars, we now know it's about 15 to 20 minutes on average, or 10 to 15, whatever it is, before the people who just pulled up actually make it to the register. So now they're able to do two things. They know ahead of time, and they can come to the person in the stock room and go, hey, Bill, instead of interrupting what you're doing, finish unloading that cereal box, but as soon as you're done, go open register number 5. As an employee, I'm happier now because I can finish my tasks. I can have a little heads up. If I have to run to the bathroom, I can run to the bathroom. I open the register. The customers are happy because the registers are just open when they need them. They are not reacting to it. Again, no customer has any clue this is happening. They just know when they go to the store they haven't been caught in a line in a while. And these are the kind of examples you're going to see again and again. So just to close out, imagine though the problem of big data, because it'll always be bigger, back to my point. The video game industry has been inundated with data, especially the online games now. They capture every button press and controller move, which is maybe what, a couple moves a second even for the really high-end players. Now we have already these body-activated games. You're going from a couple times a second to every body part I have in 3D space every millisecond with a direction and velocity attached to it. That's massively bigger and more complicated. You go from web clicks now, whether it's a Google Glass scenario, even a mouse cursor. Well, every millisecond, exactly what pixel am I focused on as I decide where to click? So I hovered over here, then I went over here, then I decided to come back here and click. It's massively bigger. Health data. The health care industry is groaning under the data. I mean, even X-rays and MRIs now are actually data. They're not images. I mean, they're images, but they're not on film anymore. They're all data. They're analyzing things. We're collecting information on ourselves. These Fitbit-type devices are already getting more sophisticated. I suspect in a few years I could almost fill up this laptop with just my and my family's personally collected sensor data, let alone what the hospitals and doctors are all collecting. It's massive. So the point is, you can't sit back and wait because all of this is coming very soon to us. It's already here in many ways, and the organizations that haven't started trying to get ahead of it are getting left behind. So with that, we'll open for Q&A. If you'd like, my contact information is here if you come up with some questions later. As we mentioned, I've got 5 copies of the new book, and just for kicks, I brought one of my old book here that we can give away tonight. And I guess for the rest of the time, we can just do some Q&A. Thank you.
If it's all right, I'd like to start off the Q&A.
Okay.
So recently, Teradata announced a big strategic partnership with Cloudera, and you have partnerships with lots of other kind of third-party customers. What are some of the tools, either with Cloudera or other partners, that kind of really help enable this discovery analysis?
Excellent question. So what we've done is we've actually embraced Hadoop because it does certain things really well. There's other things it's not very good at all. Same goes for relational technology. And what we've been approaching is this idea of a unified analytic environment, right, where you can have data in Hadoop. In our Teradata platform, we have a separate discovery platform that's like a hybrid. It has relational and parallel file systems all intermixed. And what we're doing as well is putting a layer on top of that. So the idea is this. If I'm an analyst, the last thing I want to have to do is go log on to Hadoop, maybe write in Java or something, submit something, then go log on over here on Teradata, write some stuff in SQL, go over to SAS or R, write some stuff, and then write scripts to move all the data back and forth to combine it and do it. That's just a bunch of grunt work. What I want is a single entry point where I see the information available to me and I write the analytic logic. So what we're doing with Cloudera and Hortonworks and so forth, as an example, and with our Hadoop appliances is you could, for example, enter through our discovery platform, see all the data there, also views into Teradata, into Oracle, into Hadoop, wherein as a user, I don't even have to care where that data is resting. I just write the analytic logic that I would like to apply to it, and then we'll work through the optimization of getting that data moving around. Now, in a production environment, you're going to have to be careful about how much you're actually moving it around, and you'll probably end up shifting data to optimize the process. But for discovery, it's amazing now because I don't want to worry about it. I can enter, I can use one tool set. So a lot of our analytic tool set partners, whether it's SAS, SPSS, we do a lot. We have some great new announcements with R. All of those now, you log on, whether it's starting at Teradata, starting at our Astra discovery platform, and then you see all the data and you write and you focus on your logic. And to me, that's a huge thing because the specific place that data is stored is not something I think the average person should worry about. And it's not historically different. If you go to any system today, or take our Teradata system or any other product out there, there's different nodes, there's different disks within those nodes. Do you ever care, well, what node? Is it on node 1 or node 10? And is it on disk number 1022 or 1000? You couldn't care less. You just see there's information called sales or web clicks. Why would we want it to be different just because there's different types of platforms? So same thing even with JSON, like MongoDB. JSON data, we now have a connector. You can JSON's a native data type now. You can just load the JSON right in and just start querying it using your plain SQL or in your discovery platform, MapReduce SQL, whatever else you want. And so I think that's one of the shifts that the industry is moving towards, is we need to abstract it back to let analysts focus on analysis, not on a bunch of grunt work data work, and particularly having to use multiple languages and entry points.
When you were talking about operational analytics, you basically said it doesn't have to be real time, and you talked about decision time, but sort of decision time in your example meant I analyze events as they come in, which I would say is the real defining characteristic of real time, not some time bound, right? It's instead of looking at a bunch of data and aggregating it together, you need an algorithm that takes events individually and can update a model or an aggregate. So I wanted to get some clarification on that.
So let me give you an example. Let's just say, I'll make up an example, that I'm a business and well, Chick-fil-A tonight, they forgot our plates, right? So you're gonna get some kind of refund. Maybe they've agreed to the refund, and they're going to process that refund tonight and any other refunds they have tonight. After they close the books, they'll then process through all the refunds. So if there's some fraud analytics that have to be run, okay, maybe mid-dinner hour, you just don't want to put any extra load on these systems. So you hold off. You say, you know what, we don't need to actually know if it's fraudulent till 10 p.m. So we're going to hold off running that process now, because we know that we have to check it, it's on the list, but we can wait for 2 hours till the dinner rush is over, because we actually don't need to know if it's risky or not until 10 o'clock. So there are cases where, just for the purposes of balancing the loads on the systems and so forth, it may be beneficial to hold off doing it. Now, my example I gave you, it has to be sort of near real time because of that interaction one, the bank one. But there are other cases, you know, for example, IRS with tax fraud, which they do a horrible job with tax fraud. It's about 2 weeks before they actually send that refund. So from the time you submit the tax return, you've got the better part of 2 weeks to run any analysis that you want. So it could come down to, you could say, we're going to batch run all of our fraud each weekend so that the system's available for people during work hours to do their work. So that, I guess that's where I'm coming from. You don't have to go and kill yourself to make the tax fraud run the minute I hit submit at a lot of extra expense, if running it on the weekends is just fine, which in that case it would be.
Thank you. This is good. I like your comment in regards to creating one team of IT and analytics all in one, embedding them. However, coming out of 4 years, almost 4 years of real life experience with this, with large organizations, it becomes a problem of significant proportion, mainly because, number one, the platforms are different. Number two, the skill set are different. So, for example, those that build the application would need a combination of Python, JavaScript, etc. While probably for analytics, they need just to be able to put in JavaScript with particular tags. The ownership becomes a bit of a problem, and managing massive amounts of data and requirements in a large organization makes it even more difficult as to who actually owns the code, and it becomes the developers who spend most of their time supporting the application itself, and the analytic team become kind of a side partner, unwilling, but nonetheless having to accept that ownership being handled by IT. So commonly, to embed them in one organization, they have little in common, even from standards and processes and procedures. They don't share the same conversations even. I'd like to hear your opinion on that.
So I actually wasn't suggesting that IT and analytics would become one team. I'm suggesting they're going to have to work together. So I think some of the issues you just mentioned absolutely are true, and that gets back to the ownership point I made a little bit ago, which is part of there's a middle ground. Early in my career, for example, there would be cases where as I developed a cool new analytic process, no one else necessarily had a clue what it was doing. I'd have to be, and because it wasn't part of the systems, it was my own system, there was no one else who could run it than me, and I end up, the more successful I was at creating good analytics projects, I worked myself out of my job because now all I'm doing is running production processes. I had times where I was spending well over half my time babysitting all the production jobs I had to run on my side analytics system, which is, again, horribly inefficient. I think the key of what I'm discussing is if IT and analytics can partner, I can kick over some of the day-to-day babysitting all these other things to IT. I still have to own the logic. And the fact is the logic breaks far less frequently and requires far less care, but it does have to be accounted for, and that's part of that difference. The analytics team has to budget and accept. I got to give up 10% of my time because there will be things breaking here, and that's part of my job. And if I'm going to grow analytics impact, that's part of the necessary evil, right? It can't all be the fun work, and that's hard. Again, early in my career, all I wanted to do was the fun stuff, and I wanted to kick it over. But when you start to operationalize this stuff, it's unavoidable that someone from the analytics team is going to have to be on call with the beeper for the weekend, just like somebody that manages all the servers is on call in case the server goes down. In case one of these analytic processes go down, I'm the guy for the weekend that gets the call. I might not be able to fix all of it, but I at least know who is the person who built this, or which team built this, which package was it in. Can I fix it, or is there someone else I can call? I think what it does do, it's back to making it an enterprise class organization for analytics. You're going to have some enterprise class production support. And I think that's true of a lot of departments, right? I mean, the finance team has people, somebody's going to be on call for finance when something weird pops up on the finances over the weekend, and there's some odd pattern of deposits or withdrawals, for example. So I think it's just changing a little bit. It comes back to the hardest part of all this is actually not the technology or the analytic methodologies as much as the culture and process change. And that's something that I know it's cliched to say that, but it really is true, and the resistance is almost always from those angles, right? The technology today can solve all the problems that almost all the big organizations have. That's a fact. All the technology is caught up and able to handle it. It's really the decision to use them to the maximum extent possible and to change, that's the hard part.
The mic works?
Yes.
Hi. Bill, thanks for the presentation. To transition to the discovery model that you presented, can you share how you convinced big companies that have very rigid processes to buy into the discovery model where the results are not guaranteed or measurable or anything?
I think the key is that it's two things. Well, first of all, because it works. So what we typically do, you go and you do a proof of concept with them. You say, let's take some of this data that you haven't explored yet. Like that, a couple of examples I walked through today. That's where those results came from. Some healthcare companies, we've gone in and said, you know what? Let's look through your claims history if you're an insurance company, and let's look at patterns that lead to, let's say, a hospital readmission later. And you can look, again, it's not about any individual. There's no customer IDs or identifying information, but you're looking at the pattern and you identify, wow, did you know that this is occurring? And once they see it, they go, this is great. And the fact is, as I mentioned, discovery analytics has been happening for many, many years. That's what every new cool analytic started with a discovery process. I think the key is it used to be that there weren't a huge volume of discovery potentials at any point in time, and people like me would just sort of squeeze it in, right? We would just do it. It wasn't officially budgeted. It was possible to do it around the edges. With all the big data sources coming and all the new analytic demands, it starts to be that there's more than we can just squeeze in. We've got to formalize it and get people to buy in. But I think the key is, all you got to do is try it once. Give that first 6 months and those first 10 problems, see if it doesn't pay off. Right? And if you pick your problem smart, it'll pay off. And then guess what they do? Hey, that was really cool. That $500,000 generated us 3. So you're telling me, do you think if we gave you $1 million this time, do you have enough ideas? Well, yeah. And then you find there's a certain point you hit the equilibrium again where you don't need more money than the number of good ideas that you have, but you then self do it. So it's actually very possible to start small. So to give you an example, I don't think I covered this topic. You don't need all of the sensor data from every engine of every automobile sold this past year to do analytics on whether that sensor information can help you predict automobile engine trouble. You need enough sensor data from enough engines to identify if the pattern's there. Once you say, wow, look at this great pattern, that might justify collecting all of the sensor data from all the automobiles moving forward. But you don't have to go and start with all of it first. It gets back to that point about starting the right perspective. You can prove a lot of these things very cheaply with a very small amount of data. The rollout may be very big and costly, but you've proven it, and that's how you get the justification. So I think that's where it comes from. In the end, it really does help mitigate the risk, and when you've done a prototype, you understand the data, you understand the process, and now that confirmatory analysis and the rollout are much more tightly scoped and you know, maybe not ever risk-free, but you know, not risky anymore.
Bill, my question, can you go back to slide 21?
21. All right. Oops, this isn't the computer. You know what? Let me just hit back because I don't want to. Oops.
Go ahead and ask it. How important do you think it is to have an analytics degree within the next 10 years? I think the Master's in Analytics is the next MBA.
Oh, wait, it went back to being it. 21. Can I type 21 here and will it go? Yeah, so yes, Master of, so interestingly enough, about 4 to 5 years ago, the first Master of Analytics or similar title degree came to be at North Carolina State. That's actually where I got my stats master's degree. And since then, it's amazing. So I'm on the Informs, the Operations Research Organization, has a Certified Analytic Professional program now. Oh, okay, the Picaran. And I'm on the advisory board for that. And literally, about 6 months ago when we had our annual meeting, one of the things we did, we said, let's get a current inventory of all the universities that have these programs. And after about 10 minutes, we had about 50. And we all agreed that we were forgetting other ones. Because I swear, even last week, I spoke at an event at University of Tennessee. 2 different people came up that were from other universities, said they now had a program. And I actually can't even remember who they were at this point. I mean, I hear so many now. So I think it's going to be as ubiquitous as an MBA. I think a lot of MBA programs are morphing into it. And what I'm seeing is some business schools are doing it as an extension of a more technical MBA. And then some of the traditional stats or operations research math departments are doing it as a more businessy one there. And NC State even went further and started a whole new department or school that borrows from both of those. Because apparently in university there's a lot of politics, and it's hard to have a business teacher teach in the stat school and vice versa, and they didn't want to mess with it. So they just said, we'll make a whole different thing where everybody can go play nice there because it's not anybody's enemy. And ironically, a lot of the professors I've talked to say that's true at their school. Yeah, well, we'd love to do it, but we can't have the business professors come and teach. It just won't ever happen. But I think, yes, it's going to be a huge thing. It will meet the demand. And I think the idea of having a pure business degree without any understanding of analytics and so forth, that you're not going to have a very good market value soon. And I know that NC State, last year their figures came out, their starting salaries were on par, if not above, the top MBA schools now. So these are not only getting people hired, but getting hired even at rates equal or higher than like Harvard and Wharton business schools. So it sort of proves the demand. And I think, in fact, were you the one telling me earlier today, you're in the Northwestern online program, right? Yeah. So how many people here are in or have already been in one of these masters or programs? Anyone? If I had asked this question 3 years ago, there would have been no hands. And if I said, has anyone heard of a program like this, there would have been no hands. So I think this is progress. We got 4 in here, and probably, how many people had at least awareness that there were such programs now? See, there you go. That's awesome, right?
Well, great discussion tonight. I agree with a good number of things you've said tonight. Early on, you talked about monetization, and so there's going to be some return on investments looked at in these projects. Later on, you used a great analogy about financial planning and that of risk taken by a venture capitalist. So could you explain more, as a vendor yourself, Teradata, I don't think you can go to too many customers and say, hey, we'll hit out of the park every, 1 out of 3 times, but those other 2 times, you're going to have to take a risk on that. Explain a little bit more on how to put together that portfolio of success.
Yeah, so what it would typically be, so all right, for example, like with our enterprise class systems, they have a lot of features for enterprise level deployment, right? You're not going to buy an enterprise class system just to do the venture capital model. What you can do, though, is once you've justified that enterprise class system for all of the financial reporting and all these other things, you can carve off 5% of the resources to dedicate it to a discovery process, and that's what we often have. Or now with our discovery platform, it's inexpensive enough that you can go to an analytics department and say, you can out of your budget fund this. So one big thing I think has to change, and I didn't talk about this today, this was my blog either last month or the month before. I think the way we budget today is hugely inhibiting. So how many people here have heard that statistic that Gartner claims that chief marketing officers will spend more on technology than chief information officers in like 4 years? If you haven't heard it, that's been a claim. I think that's actually pretty ridiculous for two reasons. It really doesn't make sense for chief marketing officers to be spending a lot on technology because they don't necessarily understand it, and it's not going to be good for the organization. But I know exactly why it's happening. It's because of this. And this is where I sometimes, you know, I come from as an analytics guy where you know, I beat up on IT a lot. But there's a lot of times where you got to be fair to IT. Here's what happens. All the IT departments are under pressure to keep their costs down. Right? The CIO is told your budget is flat or going down this year, period. Here's the problem with that. For the keep the lights on stuff, the true infrastructure stuff. So let's say you have Teradata. This complex of Teradata here supports the day-to-day financial reporting, the day-to-day call center stuff. It is more or less infrastructure, right? It's doing what it does. You want to keep that cost down. Here's what happens though. The marketing team says, wow, here's this new data source, these new analytics that's going to generate us $10 million. It's going to take a $2 million investment in technology. The CIO and his team are actually unable to support that. Why? Because they've been told keep your budget flat. If they spend that extra $2 million, they don't get any of the benefit and any of the kudos for the $10 million profits the company generated. They get beat up for having spent $2 more million. Therefore, they say can't help. Therefore, the CMO goes, this is stupid. I have a business proposition. I'm going to go buy it myself. So what we have to do in this area of monetization is to change how we budget to say, okay, this pool of IT stuff is the keep the lights on infrastructure. That has to be flat. But these 10 Teradata nodes are that. The marketing team funded these extra 2 nodes, and they get that extra 2 nodes of capacity to fund this project that they've committed for $10 million. It's tied to that. These 2 nodes cost do not hit IT's budget at all. They're part of this project. This discovery platform was paid for by the analytics team for their portfolio of analytics that they're exploring this year. That doesn't come out of IT's hit. That's going to get charged back to the business directly and tied to that revenue. I think it's just a simple fact of realizing that not all quote, IT expenditures these days are actually the keep the lights on infrastructure. They now can be and are revenue generating directly in the line of revenue, and we have to change that. And that's a not insubstantial cultural and policy change, but again, it really isn't that big of a change practically because it's still paying the same money for the same equipment. It's a matter of whose budget does it come out of, and it's a matter of how are you going to maximize it. I'd argue to have IT actually go through with the purchase and actually get it implemented alongside their other equipment and have it all integrated is going to be far better for the company in the long run, and let the marketing team focus on the marketing on top of that, right? When we do it separately, it just seems silly. So that's one of the things I think we really have to change. I think it ties a little bit to that question from a moment ago as well.
Thanks for the great talk. Coming to the point you were making about the mass production of analytics going forward, do you think that the emphasis on understanding the underlying methodology behind what goes into all these packages is important going forward? Like as a statistician yourself, what would you suggest that analysts going forward focus on?
Yeah, so I guess here's the key. Absolutely, the people building these processes better understand everything that's happening under the hood, right? In other words, if I'm going to be using a tool, even if it has a nice user interface and it masks a lot of what's happening, I better understand what's happening because it's very easy to apply methodologies incorrectly. And the fact is, this is one of the arguments I had with, just give you an example, is that our research and development arm, when I was talking to them about some of the R stuff we want to do, without getting all the gory details, there's a point, some of the stuff might be node parallel instead of system parallel. Point is, our IT guys were all concerned about that. Our research and development guys going, yeah, Bill, the problem is now we can't tell if the code they're submitting is node parallel appropriate or not. They're going to make these horrible mistakes, and then they're going to, I said, wait, guys, I said, I don't think we have to worry about that from this perspective. I said, first of all, the people that are going to be doing this are sophisticated enough, they'll know how to code correctly. But I said, second of all, even with SQL, You check syntactically that it's syntactically correct. That does not mean that that syntax correctly addresses the question they're actually trying to answer. If they join by the wrong criteria or forget a join criteria, they're going to get a wrong answer, and they won't know it. They don't even have an error. So I don't think it adds, I don't think you know, it's not a matter of you add risk or not if someone, putting the things on someone to understand. I think you always want someone who really understands what's happening to have that. So it may be, you know, I don't invert matrices every day. And so these master's degree programs, I would say, would I encourage that people have to sit and hand invert matrices to prove they can, like I had to do? You know, I don't think you need to do that. Would I say you need to understand why a matrix is being inverted and what that leads to as you do a regression? Absolutely. And then the tool you use, you better understand under the hood. And that's, I think, part of it. And back to the hype around big data, right? This idea that there's magic buttons that just do stuff, I just really disagree with. I look at it as productivity tools for people who do know what they're doing. You give me a, quote, magic button that I understand what it's doing, then I can maybe crank out more iterations of more analytics faster, and I'll know and be able to interpret, did it really do what I thought it was doing? Versus you give it to Bob, the marketing guy, and he could get in all kinds of trouble. Because even something as simple as building a churn model, well, how did you define churn? What are the things you're going to predict? Have you accidentally used information you shouldn't, right? Like I know the financial industry has to be incredibly careful of, you know, if somebody accidentally put in something, a factor about race or gender, they're going to get, you know, that's illegal and so forth. There's a lot of these little things that people need to think about. So I think it's absolutely necessary to focus on the underlying things that are happening. Maybe not, you know, down to the, you know, inversion of matrix math per se, but definitely why that's happening and what it does.
So I really appreciate your comment regarding relating analytics to modern portfolio theory. I have a finance background, so I'm a little familiar with that. And I can go out. I structure my own portfolio with ETFs and such, and I can look out to Vanguard and, you know, for somebody in their 30s, I should have a mix of these particular bonds and, you know, these kinds of equities and short-term, long-term, and so forth. So I have kind of a market that'll tell me what kind of my portfolio would look like as related to a modern portfolio theory. But in terms of analytics, I mean, okay, so I'm in R&D. They're spending a lot of stuff keeping the lights on, but they want to minimize IT because it's a cost. And what you're saying is, well, IT can not just be a cost. It can be more like marketing. It can generate sales. It can highlight things. So how do you know, where can I get this data, like I'm getting from Vanguard and other ETFs and the market, that says, okay, well, this is going to, you know, allow me to mitigate the peaks and troughs and stay on top. How, you know, what kind of guide me on how I can have that conversation of, all right, this is cost, but don't look at it as a cost. Look at it as an opportunity.
Well, there's a couple things. One is kind of building a business case. So my new book, I have a whole chapter on sort of building business case for analytics, because I think it's slightly different from general business cases. It's about, back to the point, if I'm going to buy those, you know, a $2 million of extra capacity, that means I've had to have proven that I have this $10 million maybe, and it's a business case I've put together, and maybe I did a prototype that helped demonstrate that. So people won't argue if you get to that. Now, as to where to focus your prototypes, I think the advantage of retirement planning is that everybody's retirement goal is basically the same, meaning there's a point in time, the time may vary, but there's still a point in time for everyone that I want X dollars. X may vary, but a point in time I want X dollars to retire on, and will I get there or not? It's not quite as clean in the analytics thing because different businesses have entirely different types of analytics. I think the point is that just like government bonds can't be all you do, and even you know, even just really safe blue chip stocks, people, you know, might want some emerging markets and all. That's, I think, where I'm going for here, which is to say you've got to be saying, you know, we don't know what this. Let me think of an example of data that I haven't used so far today. You know, we don't know what social media data is going to do to help us understand product sales trends. But what we need is a little bit of time to play around with it because we're pretty confident it can be there. So as an example, a new product rolls out. You might be able to infer the success of it in part by looking at not just the sentiment of the tweets or the Facebook postings, but if you knew the level of influencer who was trying it. So if you have a disproportionate number of heavy influencers, the people that have a huge circle that are trying it and saying nice things, that could lead to a lot of additional viral sales versus you have a lot of people that are on the outer periphery trying it. That would indicate maybe it'll be a slower build. Again, just a theory, but we could test it. But the point is, you just simply need to have a mechanism to say, yes, you know what, in addition to continuing to incrementally build these things, we have to put aside some percentage of our resources, probably small. I'm not talking 50, you know, 2, 5, 10, I don't, you know, something reasonable that we will try and experiment in. And another analogy in two very real businesses, think about whether you're a CPG or a restaurant, they have test kitchens. These places are always trying to find the next new product. And they have a whole team that spends all year doing nothing but trying new things. And a small fraction get tasted or tried by anybody outside the kitchen, and maybe one a year at best makes it on the menu, and if it sells billions of dollars, everybody's happy, right? And so there are analogs all across business where people do exactly this model, and they think of it as this is research and development. What is research and development for silicon chips all about? It's about trying a bunch of different configurations and materials until you find one that works. And everyone goes, that's research and development. It's a necessary cost. Why shouldn't analytics similarly be? We need to be investing a necessary cost to try new analytics on new data to find out how to solve problems differently. There's no reason. It's exactly the same thing. It's just because people haven't done it, they don't think of it that way, and they haven't really realized it. I think that's back to, I think people are, as the analytics is becoming aware, I'm hoping to see that people will embrace that more. But I think it's those analogs. Most companies that would be resisting what you're saying, probably you could find somewhere in their organization, if they're big, where they're doing exactly the model we're suggesting.
Hi, thank you so much. This is definitely one of the best presentations I've ever been to.
Oh,
thank you.
Thank you.
My question
Everyone's
is about...
giggling. Is something bad? Am I getting... You what?
No, I got mine.
Uh,
So my question is about the unified data architecture that you mentioned. And you also mentioned that Hadoop is part of that.
Right.
And I'm wondering whether you think that Hadoop and Data Lake are going in a separate direction, or whether they're going to be eventually, I don't know if submerged is the right term, whether they're going to disappear into the Teradata UDA, or maybe a combination of both paths.
Well, I think the Hadoop data lake concept would be part of our UDA. I think the key is the current definition and method of a quote data lake is just fundamentally flawed in a lot of ways. So, you know, it's one of the big myths is that everyone goes, well, relational can't handle this stuff because, you know, everything has to be structured and defined and modeled before you do it. And that's not true. There are policies in organizations that say you can't load data into the system until it's structured and so forth, but the technology, you can slap data in at any time you want to. That's what, you know, our sandboxes do. Now, what you have is different data. Some of the unstructured stuff may be outside, but here's the point. To simply take a bunch of data and throw it there, once you start to define valuable analytic processes, what it means, back to my point about unstructured data, well, you found key pieces of information that actually have value that you need to use on an ongoing basis. You don't want to be going through petabytes of data every time of 1,000 that someone wants to run a query just to reapply some logic to extract 2 or 3 data points out of it for every customer or every product or every web session. At some point you say, this is something we're going to use ongoing. We need to extract this once, reuse it many times. And you're going to get back to the same disciplines that have always been around. So one of my favorite things, and one of my blogs I think a few months back, is the big data flip-flop. Right? In politics, the election's next week. Everyone talks about flip-flopping. Here's a massive flip-flop that you may have missed. A year ago even, if you had talked to any of the Hadoop community, everybody would have said, SQL's dead, it's a bogus concept, there's no need for relational, you don't want to run queries, you know, it's all about Hadoop, you have all the flexibility. Well, guess what? What is every single vendor and or open source no SQL tool doing today, including Hortonworks, Cloudera? They're all scrambling to put a SQL interface on top of Hadoop. Why? Because it makes sense. It works. It's always worked for what it does very, very well. It doesn't work for what it doesn't do well. Hadoop works very, very well. It doesn't work for things it wasn't meant to do. The best comment I ever heard about Hadoop was up at a government account. And it was actually cool because it was at a defense contractor where I was in a room where they literally had one of these lights that would say secure or not secure, meaning if it was under security clearance or not. And I didn't have it, so they had me wait outside till they went through the procedure to actually officially make the room unsecure. Anyway, a gentleman there mentioned about, he goes, what we've discovered after trying to replace all of our relational technology with Hadoop was that Hadoop was built at great expense by some companies with deep pockets to solve very, very specific problems, and it does that very well. If you have that same problem, it's perfect. If you have problems that fit in the same general paradigm, it's pretty darn good. If There's other problems for which it's absolutely horrendous. So back to the flip-flop. You have companies like Facebook, who is the ultimate build your own, don't want to buy anything, who recently, I think it was last May, they first announced about a huge investment in relational commercial technology because they were spending so much time and effort trying to replicate what was just available, and they realized they're spending more to try and develop it than to just buy it and use it. And other companies are coming around. So I think what we're going to have is each serves its own role. It's not about one being better or worse than the other. It's using each for the right place, and I think people are starting to realize that, and the flip-flop's swinging back. So I'd say, well, you can continue to build some SQL on Hadoop, but then you get into, but you're 30 years behind the massively parallel system like Teradata that we've optimized like crazy. Why spend all this time and effort to use a version 1 over here? The answer is you don't have to. You can connect it all and, and go through this. And I think that's where, again, it's not just us. I think the market as a whole is moving in this direction to where you'll, again, have a series of data platforms that are interconnected, and your analytic process will get optimized amongst those appropriately by the software. It's going to take a few years to get there, but I think that's the direction we're headed.
Makes a lot of sense. Thank you.
Time for one more question.
Last question. Yes.
Bit about profiles of people who do well in this field?
Yes. Excellent question. So it's funny. In Taming the Big Data Tidal Wave, Chapter 8 is called What Makes a Great Analytic Professional. And when I put that in the book, I actually did it because I just felt strongly about it, and I actually pondered taking it out only because I thought it was so specific that maybe general people wouldn't like it. And the twisted thing is, it shows you should always go with your gut. It ended up being one of the most popular chapters and talking points because everyone was curious. And the key is this, and actually, this is a backdoor way to get to this number 3, because I think you're the one who wanted that as well, right? So I'll tie these both together for you as a special gift. The key is that the great analytic professionals are not simply technologists, are not simply statisticians or operations research or computer scientists, right? It's actually the soft skills that really set them apart. So creativity is probably the biggest filter I have when I interview people, and it's shocking how many people who are really good at analytics have a pretty strong creative background. Maybe they're not designing web pages per se, but they probably did something in music, they were writing video games, which has a lot of creativity. There's things like the understanding the business and having the business savvy, and I liken business savvy to athleticism, right? You can have business experience, but we all know people who have been in a company for a long time who everybody knows. They might even be a VP, but everyone knows, oh, you don't want to go over to Bob there. He doesn't have a clue. But he has tons of experience, right? So it's true, unfortunately. But business savvy is more inherent. So just like basketball, we could go out and train everybody in the room with world-class coaches in basketball. Those of you who are naturally athletic will be pretty well, and we can max. People who aren't athletic, you'll get better than you were, but you're never going to be that good. I think business savvy is very similar. Some people have a natural affinity to understand and get business and want to. Those people are going to be very good at analytics. And then it's just, even the idea of presentation, this gets to the fluffy stuff, is you've got to be able to present the results. When I was early in my career, I made the critical mistake of thinking having the best results was what really mattered, and having the technically correct answer and defensible answer was what mattered. And then I got my lunch eaten by people who had inferior stuff clearly, but effectively BS'd better than I did and positioned it better, okay? And so my classic example is advertising, back to how unmeasurable it's always been. So here's what would happen. It's amazing to me. It's changed now with digital marketing and so forth, but it's probably still true that the advertising budgets of major companies like Coke and Home Depot far surpass the budgets of any of the truly measurable things like direct marketing, email, search optimization, all these things. Here's part of why, and I learned this lesson once firsthand. There's a presentation for a customer, and they want to know what are we going to do to help them generate money, and we come in, and we outline very matter-of-factly, we're going to do these campaigns, we're going to measure them this way based on last year's results, we're going to make you X dollars, and we think we've got a winner here. We just proved it, right? And then the little advertising agency guy shows up in his little Steve Jobs black turtleneck and little round glasses, puts up a presentation with multimedia. They show a family running happily through a field and a mom kissing her kid, and they throw up all these platitudes, and then the people in the room go, that's what I want my brand to be. Here's your $200 million, and Bill, you can have the leftover. And I sit and go, oh my God, what just happened, right? The thing is, they told a better story. So even when you have the analytics, you've got to take the time to make those analytics relevant and understandable for the business people so they'll take the action, you have to make them relate to it. You have to make them excited about it. They couldn't care less about a p-value. They couldn't care less about a confidence interval. They care about, if you do this, you're going to make this much money. And they care about trusting that when you tell them that, they can take it to the bank. And that takes time and a relationship to build up. So just to give you your cheat, because that was a good backdoor way into it, is the fluffy stuff, a true story. A few years ago, I borrowed someone from another team because we were short, and I remember we were getting down to the wire on a project for a company that was not sophisticated analytically. They actually had a business that was mainly creative-based, traditionally. We were the first time they'd ever tried to use their data to actually segment their customers, and they weren't even sure what this was all about. So a few days out, I told the analyst that was on it, I said, here are some outlines. I want you to put together this chart, this chart, this chart, and he kept fighting me about how he thought he could get the model a little bit cleaner. I'm like, look, this is good enough, right? This proves the point. We need to help them understand this. And my point was that if we didn't help them understand these segments and why they made sense and trust it, they weren't going to do anything with it. Then they wouldn't have value from our project. We'd be considered a failure, and then we wouldn't get any more work either, nor would they get the further value of our extra work. And he got really mad. I finally had to basically, do which I never do. But I remember this because I was actually on an airplane. And then I was embarrassed I was that guy because he got me so angry. I finally was like, just do it. I don't want any more. Just do it and get it done, and I'll talk to you tomorrow. And I hung up, and then I look, and there's like people are staring at me. I'm like, I just look like that complete jerk. But the point is, after the project, he complains to his boss, who comes to me and goes, Bill, just so you know, I don't really care. But he was all upset because he said you made him waste all this time on this fluffy stuff instead of getting the better analytics. I said, I'll give it this. I'm thrilled that he recognized that because I was afraid he didn't understand what I was asking him to do. I was asking him to spend the time on the fluffy stuff. I said, I wish he understood why, but at least I know he understood my ask because I was questioning whether he even understood that I was in fact asking him to do it. And he was thinking somehow he was misunderstanding, he was fighting me so bad. And at the end of the day, that was the key. Having a little bit better model at that point was going to do us no good whatsoever. You got to learn when it's good enough. That's not settling. Good enough isn't settling. It means you've got an answer that is really, really solid. But even the most solid answer is worthless if you don't translate it into what the people understand and act on. And that's the piece that I think a lot of analytics people miss. And that's the role, as you see in these organizations, the more senior level analytic roles, they're not doing analytics much anymore. They're more doing the political work of getting the funding and the political work of getting people to buy into the next wave of projects and so forth, right? It's unfortunate. It's a reality, though. If analytics becomes big business, you end up with these layers of some bureaucracy and some politics to weed through. And again, that's just part of what it is. Not everybody wants to do that. There will be people who will be an analyst for 30 years, and that's awesome. We have guys and women like that, and they're great to work with. There's other people who prefer to do more of the higher level strategy kind of stuff, and that's great too. You need a mix of all of that, but you can't have a successful analytics organization if nobody's focusing on the fluffy stuff and if it's not part of an expectation that you're going to do that. Got to get the axe here?
That's perfect. That's perfect. First, Bill, I want to say from the Data Science Atlanta community, thank you so much. We really appreciate your presentation tonight. It was wonderful, probably one of our best ever. For me personally, let me know when you're ready to raise that $5 million in VC. I know a guy. Thank you all. Have a good night.
Thank you.